We want to talk about solving multivariable equations. Another term for this is literal equations. And basically, the only difference in these equations than the equations we've looked at before is now these equations have several variables, and we're not going to solve for a numeric answer. We're actually going to solve for a particular variable where our answer will be the other variables, because we're not going to give you any values for any of the variables. So we can do that, and the way we do it is we just rearrange those formulas, and often we rearrange those to illustrate or to point out some part of interest we might have. We would do that really in this class, but also it becomes a very important skill in science classes, chemistry classes, physics classes, engineering classes, those sorts of things. Nothing has changed, no new properties. We still have the same properties we had before, the properties of equality with addition and subtraction, multiplication, division, and we can always substitute using the substitute property for the substitution property. So how do we go about it? Well, first of all, we want to solve by isolating the variable we're trying to solve for. Isolating means to get it by itself. In our lingo today, we're going to quarantine that variable, I guess. Get it by itself. And then in order to get it by itself, we're going to use inverse operations to do that. And remember, because of the properties of equality, those operations have to be done to both sides of the equation. So let's look at this first problem. Write it down. Gx plus b equals c. I'm solving for x. So the first thing I'm going to do is identify what I'm solving for. And for you guys, in the purpose of this class, I'm going to highlight it. I'm trying to solve for x. So if I'm trying to solve for x, when I look at it, it's g times x plus b equals c. I know that I can use the subtraction property of equality to get rid of this addition of b, so that's what I'm going to do. So it's plus b here, so I'm going to subtract b from both sides. Just like that. When I do, because these are inverses, they'll cancel out there. The additive inverse, and I'm left with gx, or g times x, equals. Now, unlike when I had, real numbers here, not variables, I could go ahead and get an answer there. I can't for c minus b. I just have to write c minus b. So it's g times x equals c minus b. Now I know the inverse operation of multiplication is division, so I can use the division property of equality and divide both sides by g. So these will cancel, leaving me x equals c minus b over g. And so now that equation hasn't changed, but it's solved in terms of x. Look at the second example. What do you think my first step might be there? Yes, sir.
Multiply 2 times x.
Distributive property. Sure, I can do that. 2 times x is 2x. 2 times k is 2k. And that'll equal m. So I use the distributive property to get rid of my parentheses. Another property I could have used was the division property, and I could have divided both sides by 2. And that would have been okay too. Both of those would work. If I did that, I would have taken this same thing here. I would have taken this, and I would have just divided it by 2, and those would have canceled. So either method will work. But I like what you said. I'm going to do what you said, which was to distribute. And then my next step would be to subtract 2k from both sides. And when I do that, inverses will cancel each other. We got 2x is equal to m minus 2k. And I know at this point now I need to divide by 2. Inverse is leaving with just x, which is what I'm looking for. So solved for x is m minus 2k divided by 2. We'll look at 2 more examples before I give you an opportunity to practice some of these. So I'll solve for x here. Same basic thing. We want to add 3 to both sides to get, remember, we're solving for x, so that's what we're after. So we'll add 3 to both sides. And those are inverse. I'm left with a negative mx equals p plus 3. Now divide both sides by negative m. Why didn't I just divide it by positive m? Why did I divide by negative m? Yes, sir.
Well, for one thing, that's technically not subtraction right there, the negative m. That's just negative m hanging out by negative 3.
We talked about that earlier when we were solving equations. You know, if you use a commutative property, can we rearrange it? Okay. Negative mx minus 3. That's the same thing. And then you look at that and you'd say, oh, yeah, that is subtraction. So the way that we are going to get rid of any number that's connected with addition or subtraction is to do the opposite operation here. And in this case, when we put a negative 3 with a positive with 3, we know that's going to give us 0. So that's kind of what we're after there. So the question takes us back now to, why did I divide by negative m? Well, a negative m divided by a negative m will give me a positive 1. Those are inverse operations with multiplication. So, I'm adding or subtracting, obviously I'm going to put the opposite sign, but if I'm dividing, I'm going to include the same sign of what I'm dividing so that I have 1. Inverse, what I'm looking for, okay? So those will cancel out, leaving me with just x. And this will be p plus 3 divided by negative m. One more example, look at the one here. Earlier we did this with this distributive property. Do we want to do the distributive property again? Yes or no? Yep.
Yeah.
Okay, let's do it then. We'll say 4ax plus 4b equals 16. So I'm solving for x. Remember, that's the goal. And so I'll subtract 4b from both sides. And when I do that, those will cancel. So I'll have 4ax equals 16 minus 4b. So my next step then is to divide. I've got 4 times a times x. I could divide 4, and then I could divide a, or I could divide 4a. And since this is all multiplication, I think I'm just going to go ahead and divide 4a here. Now it's a little bit tricky, at least at this level, because we know those cancel. I'm left with x equals 16 minus 4b divided by 4a. We're really not done just yet because this coefficient of 4 that we divided by, 4 will divide 16 and 4 will divide also 4. If those divide evenly, when we get to talk about rationals, we'll discuss that more. But we can go ahead and divide those out, and that's okay. And we want this answer to be as simple as possible. The temptation often for you guys at this level is just to leave it there. But we really need to say, well, 16 divided by 4, that is going to be 4. And negative 4 divided by 4 is just negative 1, or I have a b left. So this would be negative 4b minus b, and I divide by 4, so I'm left with a in the denominator. That's the answer that is the most simple, the answer I'm looking for. But that's a little tricky for you because you've not dealt with the rationals so much yet. So when I solve it for x, I'll be left with 4 minus b over a. So that's how we solve multivariable equations or linear equations for variables.